Let us look at this question, which I expect you to solve actually. Find the number of different 8-letter arrangements that can be made from the letters of the word daughter again, but such that all the vowels do not occur together. So that's the only difference here from the last question, that the vowels do not occur together. And the only hint I will give you is that use answer from last problem. This should be enough, and maybe subtract it from some other number. So this much I told you. It should be, I expect you to look at it. And the answers are 32,000, 12224, 36,000, and 4224. The correct answer is 36,000. So let us look at the solution. So what we have to do is that, as before, we have these 8 distinct objects, right? And we have to form 8-letter words where all vowels are not together. So we had already identified 3 vowels, which were A, E, and U. And how can you have 8-letter words where all vowels are not together? So you can have either no vowels together or only 2 vowels together, right? So no vowels together means that any arrangement which is like AE or EA, this should not occur in the 8-letter word. Anything UA, AU. So basically these should not occur, and only 2 vowels together is that you can have A and E together but not A, E, and U together. So that will be 3 vowels together, right? So both of these cases are possible. So it will be a very complicated question actually if we had to solve it using this method. But I told you, I gave you the hint that you should use the answer to the previous problem. And then you can just say that 8-letter words where all vowels are not together, that is equal to all 8-letter words minus what? 8-letter words with all vowels together, right? So this is 8-letter words with all vowels are not together is equal to all 8-letter words and 8-letter words with all vowels together. So just see this expression. We have used this subtraction principle before also, but this comes again and again. So please try to use it whenever you see a difficult problem which cannot be solved directly. Try to use something like subtracting something simpler from the complete, like all 8-letter words. So what are the all 8-letter words which can be formed from 8 distinct objects? 8 factorial, right? So I just wrote 8 factorial. It is 8p8, but I just want you to get a habit of writing 8 factorial if it is 8p8. So I'm just writing like arrangements of 8 objects taken 8 at a time. That is 8 factorial, and minus 8-letter words with all vowels together. So we had solved this before, but you should solve it again and again to practice. So you will have like 6 factorial multiplied by 3 factorial, right? Because you take 3 vowels as one object, so you have 6 objects, and 3 factorial is the arrangements of the vowels within each other. So this gives you an answer of 36,000. So this is the answer, and the key point I want you to remember is that subtract from total if easier than computing directly. So this is like a very important thing. You can always try to use it whenever it's possible. So here also, like we said, that you see this is the total all letter words, and I'm subtracting this 8-letter words with all vowels together, which is easier to compute than computing the question or problem directly. So this is very important if you remember it. So please, I'm again highlighting it, subtract from total if easier than computing directly. Okay.